Hi there, my name's Paul from Mira Showers. I hope you're all keeping well. One of the things we thought we'd do at Mira was to compile a series of videos as part of your CPD as installers and to give you a few hints and tips so that when everybody gets back to work you can troubleshoot and fault find some of our products if you ever encounter issues in the field. I hope you find this series of videos useful. If you do have any questions or even any requests as well, then feel free to get in touch and we'll look to address those too. Thanks for watching. Another common symptom reported on electric showers is a cold only fault. If this is on the first installation, the first thing that we'd recommend that you do is record the maintain pressure. All electric showers have a minimum maintain pressure, normally around 0.7 bar. This is just to ensure that the shower doesn't start dry and heat up the elements when there is no water there present to cool it. This is of course the maintain pressure, or the working pressure as it's commonly known, so you will need to run another outlet in the property in order to replicate that water running through the shower. But if you don't have 0.7 bar, that's a common reason why an electric shower won't get hot. The next thing to check is the filter housing, just to ensure that no debris has blocked the filter and prevented the flow of water through the unit and caused it to overheat. Because this requires the removal of the case cover, we would always advocate that this is done by a competent person and that a safe isolation and lock-off procedure has been undertaken. Removing the filter and rinsing under a cold tap should do the trick. If the shower's been installed for a while, the next best thing to check is the handset and the hose is free from obstructions. Just ensure that the handset isn't blocked, kinked, obstructed in any way. And the other thing to check is just that the spray plate itself is clear from blockages and no scale or deposit is blocking the spray patterns itself. All Mira showers come with rub-free nozzles. Just agitate the scale just to ensure there's no back pressure being created in order to cause the shower to overheat. If having done those checks and the problem still persists, it's likely that the heater tank might need replacing because of scale. All Mira electric showers contain clear scale technology, which slows down the build-up of scale by up to 50%. If it is the heater tank that needs replacing, I'll show you how to do that now. A good indication that the heater tank might need replacing is that the thermal switch may have operated. The thermal switch monitors the temperature of the heater tank and operates at 48 and 75 degrees. At 48 degrees, this is normally represented by the temperature cycling in the shower. If it reaches 75 degrees, it will operate indefinitely and result in the cold only fault. Using a multimeter, test for continuity across the thermal switch. If no continuity exists, the thermal switch must have operated. To help the removal of internal components, it can sometimes be useful to loosen the screws on the saddle clamp. Because this particular model is thermostatic, you'll also need to remove the temperature timing belt from the front of the flow regulator assembly. The next task is to remove the 3 screws which secure the flow regulator assembly and the heater tank to the back case of the shower. Although all Mira approved spares are provided with a wiring diagram, this is a good time to catch a few pics to help with reassembly. Remove the wiring from the top of the heater tank, leaving the earth till last so as to keep the thermal switch in place when doing so. Because new Mira heater tanks come supplied with new microswitches, you'll need to remove the old ones by removing them from the switch assembly. Removal of the microswitch from the switch assembly is easily done with a slotted screwdriver. Careful removal of the wiring from the microswitch is also necessary, as these wires will need to be used later. When reassembling, ensure the rubber boot remains in place and that the spade connection is pushed fully home and is tight. Any signs of overheating will require replacement of the wiring pack. The heater tank assembly can now be removed from the shower. For reassembly, it's worth noting the location and the type of O-ring used to seal between the heater tank and the flow regulator assembly. Non-thermostatic showers will only have one water inlet, unlike the one pictured here. When it comes to reassembly, it's best practice to place the smaller of any connector onto the larger one before tightening any final electrical terminal. A 3mm separation gap is also recommended between electrical terminals. Once all the electrical terminals are in place, we would always advocate double checking to ensure complete electrical tightness. Other than reassembly now and checking for leaks, I don't think there's anything else that you're going to need my help for. Hopefully this has proved useful to you. We would always encourage a full functional check of the shower after any repair, and where possible an earth fault loop impedance test, just to ensure that the shower continues to operate safely and within the regulations. I did say right from the very start we're absolutely open to suggestions and requests from you guys, so I look forward to hearing from you.